Okay, so a couple of questions that you had. So what I usually do for that is, what I'll do is I kind of set up a similar one. So this is going to be similar to number 5 on your hand. This one will be similar to number 6. And notice I just kind of change the numbers, and I'll kind of walk through it to show you what you need to be doing. And of course, you asked about 9 as well. So I've got a similar one here in number 9 as well that we'll be looking at together. Okay. So let's go back to the beginning here. Okay, and it says find the common ratio and terms in between the geometric sequence. So geometric sequence means that you're multiplying, right? So luckily for you and I, that we know the first term. That's always key. If you don't know that, you usually have to use 2 equations, but in this case, we can get away with 1. So we're using the geometric equation for a geometric sequence. So to remind ourselves, that's Tn equals T1 R n to minus 1. Okay, so we know T1, it's right here. We know T5, so that's where we're going to put it there. And then we know the n is going to be 5 because it's going to be the 5th term. We're going to put it there. So we end up getting 12,500 equals 4 R 5 minus 1. Okay, so then if we reduce that 5 minus 1 to 4 there. Okay, so what we have to do is we have to get the R to the 4th by itself. So we're going to divide that out on our calculator first. So 12,500 divided by 4. So that's 3,125 equals something to the power of 4. Now, we don't know logs yet, and that doesn't happen until grade 12. So what we have to do is kind of guess and check here. So 1 to the power of 4, 2 to the power of 4, 3 to the power of 4, 4 to the power of 4, 5 to the power of 4, 6 to the power of 4. Which one of those is going to fit? Or is it going to be in between? So I'm looking at a fairly big number. 2 to the power 4 is probably too small. 3 to the power of 4. Let's try 4 to the power of 4. So go on your calculator, type 4 to the power of 4. Okay, and it's only 256. Okay, 5 to the power of 4. Let's try that one. 625. Let's try 6 to the power of 4. Okay, we're getting closer. 12 something. Let's try 7 to the power of 4. 24, so that's close. It's going to be 7, maybe 8. Okay, it's too big. So it's between 7 and 8. 7 to the power of 4 equals, and 8 to the power of 4 equals 4,096. 7 to the power of 4, if I do that again, it's 2401. So we're looking at R is about maybe halfway, so try 7.5. 7.5 to the power of 4. Okay, that's really close. So we'll say 7.5. That's close enough. Now the one in your handout actually works to a nice whole number. It'll be a whole number, but this one didn't. So now how do you get the rest of the terms? Well, you go 4, then you just multiply by 7.5. 4 times 7.5, that's 30. Then you multiply by 7.5 again, 225. Then you multiply by 7.5 again. Okay, about 16,807.5. And then the last term should be our 1200 if we multiply by 7.5 again. So it gives us approximately 12,656. It's a little bit big, but I rounded off, right? So that's approximately how you would do it. Now yours is going to work out so that it works out to an even number in there. And that's kind of the process that you would follow there for first question that you asked about 5. Okay, the next one that you asked about, 6. Okay, 6 was the photocopy question. Okay, so let's do a photocopy question. Okay, if I photocopy an original at 78%, how many copies will it take to get down to 12% from the original? So there's a couple different ways to do this. The easiest way is just to write it out. Okay, and you don't have to worry about a formula then. That's what I would do. So let's say that the original is 100%. Okay, so let's say that we start with the original being 100%. So we'll say it's 100. That's the original. Now we're going to multiply. R is going to equal 78%, 78 out of 100, which equals 0.78. So every time you do a copy, you multiply by 0.78. So this would be 78. Okay, and then we're going to multiply 78 by 0.78 on our calculator. And we're going to get 60.84. And we're going to keep going until we get to 12. So then we multiply that answer by 0.78. We get 47.5 approximately. Okay, then we're going to multiply that again by 0.78. That's 37.0. Okay, and then we're going to multiply that by 0.78 because it's still not at 12. That's 28.9. Okay, and then we're going to multiply by 0.78. And I get 22.5. $17.6, getting closer. $13.7. And our final one. Okay, 10.7. Okay, so it says how many cups it will take to get down to 12%. So that's 1 copy, 2 copy, 3 copy, 4 copy, 5 copy, 6 copy, 7 copies, 8 copies. Still not down to 12, so we got to do one more. 9 copies, and it's a little lower. So you'd say 9 copies. That's the easiest way to do that. You could do a formula with that one. If you did the formula, it would be, you would go Tn equals T1 times Rn minus 1, and you would go, your Tn would have been the 12, your T1 would have been 100, and then your R would have been 0.78 to the power of n minus 1, and you'd have to you'd divide this out to get 0.12 equals 0.78 n minus 1, and then you'd have to just raise this to power until you got that answer on your calculator. This way I find much easier if you just write it out. It's not that long of a question. So that would be the more effective way to do it. Okay, we'll go on to your final one that you asked me about, and that was 9. Okay, I've got a similar one to 9 here. Okay, the numbers are a little bit different. It says determine the number of terms in a geometric series below. Okay, so we're going to still use the geometric sequence idea. Tn equals T1 R to the n minus 1. So our first step is to find r. So r is always equal to the second term divided by the first. T2 divided by T1. In my case, that's 40,000 over 80,000. That equals 1 over 2, or a half, 0.5. If you do decimals, Molly, make sure that you don't round them off too much if you use a decimal for your R. Keep 3 decimal places or something like that so that you can get close to the right answer. Okay, if you use fractions, you'll be fine. Okay, T1 is given there. So then all you're going to, and this is Tn. So all you're going to do is plug in the result now. Okay, so Tn is, we're going to put it in this formula. So we're going to go 625 equals 80,000. R, which is 1/2 or 0.5, to the power of n minus 1. So this is going to be another guess and check question. So you're going to divide 625 divided by 80,000 first. So go 625 divided by 80,000. And you get a really small number, but don't round it. Okay, write it out. 0.00078 equals 0.5 to the power of n minus 1. So now what you got to do is try numbers until you get this. Okay, on your calculator. Remember, your power button on your calculator either looks like this or like this. So what you got to do then is you go, okay, 0.5 to the power of, I don't know what it's going to be. I'm going to guess, let's try 10. Okay, 10 is 1, 2, 3, just about, it's just a little bit big. So 10 gave me, it gave me 0.000976. So we're looking for a little bit smaller. Let's try 11. Okay, that's too small. So it's between 10 and 11. Okay, so I'm just going to pick 10 because it's closer to that than 11 is. So we'll say that this then would be that this would be the same thing as saying 0.5 to 10 equals 0.5 to the power of n minus 1. So that means the 10 that you found equals n minus 1. So then you just add an extra 1 to it, so n is going to equal 11. So that would be 11 terms in that particular sequence. Okay, that's an example like 9. So this one was like 9. This one here was the photocopy question like 6. And this one here was like 5. Okay, they're all geometric series and sequences. And hopefully that'll help you out, those methods of doing these 3 examples here. Okay, they're not the exact examples. You can work out the exact examples on your own sheet. Let me know if this helped you out and got you pointed in the right direction. Okay, if not, just text me back and maybe we can meet, get together live on video and work something out if it doesn't help. Okay, so I'll send this off to you and good luck. First, I gotta find where my on-off button is here. There it is. All right, so I'll send this off to you. Good luck.